Alright guys, in this video we're going to finish taking notes on absolute values and inequalities by combining the two, solving absolute value inequalities. So before we jump into inequalities, let's remind ourselves that when we have something like the absolute value of x equals 3, this really says in English that the distance between x and 0 is 3. And if we look at that on a number line, we know that x must equal 3 and negative 3 because those are the two numbers that are 3 units away from 0, negative 3 and positive 3. So if I then write the inequality absolute value of x is less than 3, what I'm really saying in English is the distance between x and 0 is less than 3. So let's think about a number line with this one. Here's 0. All the numbers that are less than 3 units away from 0 are between negative 3 and positive 3. So it's all these numbers here, not including negative 3 and not including positive 3 because those numbers are exactly 3 units, not less than 3 units. So we would use the inequality negative 3 is less than x is less than 3 to represent all the numbers that satisfy that statement. So notice how an and compound inequality was created for our less than inequality. Interesting. And if we look at our last possibility, that the absolute value of x is greater than 3, this says in English that the distance between x and 0 is greater than 3. So we want all numbers that are more than 3 units away from 0. So again, taking a look at our number line, we go 3 units in this direction and 3 units in this direction. And that ends us up at negative 3 and 3 again. And we want all the numbers that are more than 3 units away from x. So that's all these numbers over here. And that's all these numbers over here. Every number smaller than negative 3 and bigger than 3. So numbers that are smaller than negative 3, like negative 4, that's more than 3 units away from x, or numbers that are bigger than 3. Notice how an or compound inequality came out of our great or than 3 inequality. Alright, so if you didn't catch on with the last slide, anytime we have a less than symbol, we're going to be thinking of an and compound inequality. So here we go with some of our fancy math writing. If we have the absolute value of ax plus b is less than c, so if it's a less than symbol, it can be written as the solutions can be written as negative c is less than whatever's inside the absolute value bars, which is less than c. So less than creates an and compound inequality. Let's try an example. If I have the absolute value of 9 minus 4x is less than or equal to 5, since the symbol is less than, I think less than, I'm going to sandwich the middle of my inequality, so 9 minus 4x, between positive 5 and negative 5, which when I solve by subtracting 9 from both sides, I get negative 14 is less than or equal to negative 4x, which is less than or equal to negative 4, and divide both sides by, or all sides by negative 4, I get that 3.5, or 7/2, is greater than or equal to x, which is greater than or equal to 1. I had to change my symbols because I divided through by a negative. So these values between 3.5 and 1 are the values that would satisfy x, which we could go ahead and graph. Here's 1, here's 7.5 or 3/2, and it's a closed circle because they're included in our solutions. So now, if I'm solving a great or inequality, it's going to produce a greater than. It's going to produce an or inequality if the symbol's greater than. So if the absolute value of ax plus b is greater than c, then the solutions are ax plus b are greater than c, or ax plus b is less than negative c. You're going to keep the first one exactly the same, and then the second one you want to change the symbol so it becomes less than, and change the sign of whatever c was. Whatever c was, you make opposite. So an example of that could be the absolute value of 2x, oops, sorry about that, 2x minus 7 is greater or than 1. Since it's a greater than symbol, we're thinking great or. So the first inequality is exactly the same. The second inequality, or, we're going to change the symbol to less than and change the sign to negative 1. From there, I want to solve each individually by adding 7 to both sides and then dividing by 2, giving me x is greater than 4, and then adding 7 and dividing by 2, giving me x is less than 3. So my solutions are numbers smaller than 3 or greater than 4. Now I want you to find the online textbook and go to page 401 and do numbers 1 through 21 odd. And if you need to, look before page 401 in the textbook for help or rewatch this video. Thanks.